Hello, this video is a short little repair video, mainly focusing on how to test and identify problem components inside of a gas dryer. Our dryer made this beeping noise and it wouldn't heat. I'm not sure if the beeps were associated with the fault that we repaired in this video or if the beeps were due to the high moisture in the dryer. We recently had the house resided and the dryer flap outside wouldn't close completely. With the hot and humid airs outside, this caused the air to be drawn in from the outside through being cooled down and condensed through the dryer vents, and the condensation accumulated inside the dryer as the air was drawn into the house. I ran the dryer for a while and then the beeping noise kind of got quieter and totally went away, but the dryer still didn't continue to heat. When I moved the dryer away from the wall and disconnected from the dryer vent, the water from the condensation caused a puddle under the dryer vent. So that's how high the humidity outside was. The siding company did come out and fix the dryer vent issue. So now air isn't being drawn in when the dryer isn't running from the outside, and so that eliminates condensation problem. But now let's go back and investigate this problem here, why the dryer didn't heat. So I'm just checking the components here, that all of them are okay. Right now the burner doesn't come on, so I checked this device here. So this here is a switch that should be always in the closed position. This here is a resistor, a temperature sensor that should be 9 kilo ohm, and the position right here is on our plan the drum outlet right here. So that's the component that we just tested there. The next component that we are testing is a similar switch right here, a switch and sensor right here. So right, again, these two are the switch that should be always connected. So, and this here is the resistor, and that should be also 9 kilo ohm. So that's exactly the same device that we tested down here. And what we are looking here at on our chart, it's the control inlet switch. Then this trimmer device here, that is the yellow and blue wire go there. So this is this device right here, and again it should have been a closed switch. So we should test the continuing on that. So that device is also good. The next item that we're testing is this safety switch. We find that with the orange yellow wire. That is right here in the back, this here. And that's also tested, and that's tested good as well. The flame detector is a little sensor that's right here. It has a little viewing port in there, so it detects whether there's a flame. In obviously our test position, the off position, if you remove the contacts, you should also have continuity, so that switch should be closed. And on this, in our case, that is working. The next thing that I tested was the igniter. So the igniter is also directly connected to this here. If we see right here, that's the wiring harness that comes out of this valve, the gas valve, and that connects to the igniter right here. So I disconnected that. I used the multimeter to measure it, the resistance, and it should have a resistance, a low resistance. It shouldn't be open, it shouldn't have direct continuity, and it should not have a high resistance. So in my case, I don't have any ohm readings on it, so there's no current going through the heating element. So that means the heating element, obviously the igniter doesn't heat up and it wouldn't be able to start a flame. So that's why the system doesn't start heating for me. So let's go ahead and pull that igniter out of here. If you want to see where the igniter is, you're gonna go for a wild chase here. I need to go sideways here. So right down here, that's the base of the igniter, and there's the top. Let's turn on the light and see. You see a little bit more. So right up there is the igniter going in. So on this other side here, there we see the flame sensor, flame detect. Right here is this little rusty screw, I think. That's what I need to loosen to get to the igniter. Okay, here we have the igniter removed. Right here is the screw that was attached to this. You see right here is where the winding is broken, and all those gaps, there should continue the winding all the way to here. So obviously we don't have a connection there, so that igniter is definitely bad. So we did find out where the problem was. I'm gonna check out if I can find the other part still lying in there. So I did find this little piece here, and I think there are other fragments in there of this heating element being shattered. So yep, I need a new igniter, and maybe then this dryer works again, because otherwise it's in a great condition here. So I tested out everything till I got to the igniter. I haven't tested out the valve, obviously. The valve is closed, and if the igniter never heats up, the valve shouldn't be opening. That's what the flame sensor should be doing good on. Yeah, if you dig into this here, what you need to do is remove the top screws on that front top panel. You move the top panel up, then you pop up the front edge here, and the lid comes off. And then on the lid, right up here is a screw, and on the other side is a screw. You remove those screws, then the front panel comes out, because the bottom is just held by these tabs where it sits in. Once the front comes out, this here runs the outside of the drum. So if you haven't messed with dryers yet, right here are the little rubbing, not really bearing, but the glides on it. They often wear out, so if you start squealing, you should stop using the dryer and change out these there are two different types on it. Somebody else can tell you the exact detail why. I assume this material is kind of, I don't know, let's stop guessing around. But anyway, so once you have that out, the drum is still in there, and to really work in there you need to remove the drum. To remove the drum, first you need to remove the belt, which is this here that goes over the drum. To remove it, you need to move your hand down in here. And this here is the tensioner pulley, so you need to pull that down, and best is to go under the belt, pull that down, and then flip the belt off that pulley toward you. If you push it to the back, it will just get stuck on that thing, and you won't, yeah, it will be just crap. Once you have the belt off or loose, you can start moving the drum out toward you. You probably have to move out, push out the sides a little bit, because it kind of gets hung there. But there's a indentation. Potentially you could loosen some more screws, so you can push it more apart. and it would work a little bit better. Anyway, that's how you do it, and installation is the same thing. You have to then put the belt again on. So what's happening here is the belt runs right here on the motor around the drum, and I don't have enough hands there, and this one needs to go around like that as a detentioner, while that one goes straight up to the drum, and so the tensioner is running somewhere around, somewhere around here is the tensioner running. So the belt kind of goes like this, and the other one goes up there to the drum. Hope that makes sense. Once a drum is in there, it will be a little bit easier. Not to show, but to figure things out. Anyway, so I need to order this part here, and the next tough thing is actually figuring out what the part number is of that guy. So here's the new one placed in. I did have to adjust the connector. They were slightly different, but luckily I had the pins to replace it. So the new igniter is installed. It has 65 ohms, and now we just go ahead and reassemble everything. I'm gonna make sure to put a little bit of grease over there. That's the only place right here where the drum turns around. I just use lithium grease, that's what I have there, and then we set the drum in and reassemble everything.